So you can see where the electricity's gone down the center and it's radiated out. This here in the center where the electricity actually passed through is extremely hot and charred. You get on the outside of the grapefruit, it's actually cool. So this is actually showing how the electricity cooks from the inside out. I would pass it around, but it's kind of messy. Now, on any given day, we're dealing with car accidents with utility poles. And sometimes the power lines actually fall down on the car. You see here. You see the light lit up, and you can see the current actually going around that Mylar balloon. It's lighting this light. So there's 7,200 volts passing through that balloon around the surface and lighting this light. Kids like to let those go, but we tell the parents as soon as the kids are done with it, we want you to pop them. The Mylar floats on the wind current, and just imagine some of our transformers in our substations are $500,000 to $1 million. Just imagine that getting up between the bushings on a transformer and tearing that transformer up. And transformers nowadays are extremely hard to get. We got a demonstration on a hot dog hand. The reason we use hot dogs is it resembles a human hand. It's got a skin, it's got fat, it's got grit. Another one, we've got our PVC guy. He is acting as one of us. And we use a grapefruit to show the body, the way the electricity goes through the body. And we're going to set him up here in front and actually pass current through him. Electricity burns from the inside out. So it'll start on the bones and slowly work through the fatty tissue out through the skin. And it's coming over here to this other transformer that you have at your home, and it's coming in 7,200 volts at the top, coming out 12240 at the bottom, going through your house meter and coming out and lighting up this light. Now, some of the equipment we have on the pole, when you hear us talking about cutouts, it's these devices here. Those are generally what we have at our transformers, some of our line taps. So if we have a fault, a tree, a squirrel, whatever, a lot of times those will open because they're a one-time use type operation. As soon as it blows, it drops open and we have an outage. And we'll come out and repair that outage. Now on down, right here, we have what's called an ECR. It's an electronic circuit recloser. It takes 4 shots before it locks out. And what that does is we've got a couple fast shots, so instantaneous, it'll trip and come back on. And the aluminum we're actually using is the bones. Now electricity, if you do have a contact, it burns from the inside out. So the first thing that's going to affect is your bones. If you want to pass that around. You can look at the tips of those and see how they're burned off. So it starts at the bones and slowly works itself out. If you've had a bad contact, when you get to the burn unit, one of the first things they'll do is they'll start cutting you open. Just start making slices in your skin because the skin is going to slowly swell to where it actually rips the skin. So they're going to make places in your skin to where it actually comes out and it's so. Now in an instance like this, please do not cut that tree off the line. If it's on a power line, do not cut that tree off the line. That's our job. You have no way of knowing if that line's de-energized. That electricity will go from that power line straight down that tree to the ground. And it will be energized. We've got another one we've just started doing. We use these rubber gloves as part of our personal protective equipment. And we test them every day to make sure they don't have holes in them. We've actually put a pinhole in this one, and we have a hot dog up inside of it. So before every use on our personal protection, protective equipment, we'll actually do an air test. You can see how small that hole is if you want to pass that around. And you can see the tip of the hot dog just like the other one, but this actually had rubber glove protection. It just had a small hole in it. Talking about our PPE, our personal protective equipment. Rubber gloves with our protectors and rubber sleeves. Anytime we're dealing with primary voltages, we're in this. Along with our hard hats, our safety glasses, our flame resistant clothing, and our composite or steel-toed boots.
These are really nice. You know, they're real pretty to look at. They also can cause a problem for power companies and co-ops. They actually grow up into the line, the wind blows maybe the tree over, lightning hits the tree, and it causes a lot of damage. I want you to pay close attention to this, ladies and gentlemen. If you would, look at the top of this tree. This is a tree making contact with 6,300 volts. Now, if you would, look at the bottom of this tree. This would be where the employee would be standing, or the customer would be standing, cutting the tree off the line. It's about 11,000 degrees in 1/6 of a second. Just to prove the point of how conductive trees can be, we're going to remove the cutout on the far pole there, and we're going to bridge that cutout with a small tree limb.